Hello, this is Captain Chaudhari. In my series of videos on basic stability calculations, today I am going to do a very interesting calculation. If you throw a log of wood in the water, whether it will float horizontal or it will float tilted. Let us say we have a dimension of this log. Let us say it is 50 centimeters this way and say 40 centimeters this way. So 0.5 meters by 0.4 meters is the cross section. This is the log of wood. Now it is put in the water and it's put in seawater. Seawater density is 1.025 tons per meter cube. I might say this is the length of the log, but length is not important. As I discussed before, in transverse stability the length does not play any role. So let's say the density of the log is 0.8 tons per meter cube. If I want to find out the mass of the log, it would be the dimensions, that is cross dimensions, multiplied by the length. There is a volume multiplied by this density would give you the mass. But basically, if this log is 40 centimeter, if we are talking about whether this face will be parallel to the water, whether it will float parallel to the water, then we have to consider this as the height. The height of the log is 40 centimeter, 0.4 meters. So can I say when it floats, whether horizontal or tilted, the kg can be considered as 0.2 meters, right? Kg would be like 0.2 meters, and if we know the density of log and we know the density of liquid in which the log is floating, we should be able to find out the draft. So let us find out what is the draft, right? So the first principle, length into breadth into draft into that the submerged portion we are talking about multiplied by 1.025 is actually the mass of the liquid that is displaced by the submerged part of the log. Now this should be equal to the mass of the log. Mass of the log is 0. Length into cross section, that is 0.5 into 0.4, right, into the density of the log, that is 0.8. L gets cancelled from both the sides. Now B also gets cancelled from both the sides. So we have the draft equal to 0.4 into 0.8 divided by 1.025. Let us see what is the draft. 0.4 into 0.8 equals divided by 1.025. That gives me the draft as 0.312 meters. 0.312 meters. Now if the draft is 0.312 meters, I would say the kb is half of the draft, that is divided by 2 gives me kb as 0.156 meters. What is the BM? BM for cross-sectional area like this, BM transverse is equal to B square upon 12D. Now B square upon 12D means 0.5 square upon 12 into 0.15. D is 0.312. So 0.5 into 0.5 equals divided by 12 equals divided by gives me 0.067 meters. That is the BM transverse. So what is the KM transverse? KM transverse is equal to 0.223 meters, and we said what is a kg? Kg of the log is 0.2 meters because the metacenter is above the center of gravity. So in this diagram we would say that the center of gravity is somewhere here, right? Now the draft is 0.312, center of gravity is halfway, right? This distance is 0.2 meters, right? And 0.223 is the metacenter. That means if we want to imagine where is the metacenter, it is 0.223. It's still below the water level, but the log would be considered as stable, because if it has to roll, if it is disturbed, it will roll about the metacenter. The buoyancy, center of buoyancy would move with metacenter as swinging point. So the main thing to understand here is the km transverse is more than kg, so metacenter is above the center of gravity. So this leads to stable equilibrium, and the log can be static, log can be stable with metacenter above the center of gravity. Let's do another question where we would change the density of the log. Let us change the density of the log to be 0.5 tons per meter cube, and let us see whether the log can still float horizontal. Now in the same question, I can say that because the height is 40 centimeter, kg would be 0.2 meters, and to find out the draft, we do the same calculations. Except that instead of 0.8, I would write 0.5 here, and the draft can be therefore given by 0.4 into 0.5 equals divided by 1.025. That gives me 0.195, 0.195, and the kb would be half of that. Kb would be half of 0.195. 0.195 divided by 2 gives me 0.098 meters, right? Bm transverse will be b square upon 12d, and in this case the draft is 0.195. So that gives me the Bm transverse as 0.5 into 0.5 equals divided by 12 equals divided by 0.195. That gives me 0.107. So that is 0.107. I put it here, 0.107. So Km transverse is going to be 0.205. So now in this case also we can see that Km is more than kg. In fact, Km is slightly more than kg. So can we say that the Gm is very, very close to 0, but the log can float with the side parallel to the water level.